anybody that joins at the middle of the lecture, joins at the middle of the lecture. So I'll continue from the second part of our topic, which is current electricity. Current electricity. And we've gone through so many of these aspects. Last time we emphasized on the aspect of resistivity and conductivity. So basically this time we're going to be dealing with conversion of galvanometers to ammeters and conversion of galvanometers to voltmeters. You understand? So we're going to start with the first one, conversion of galvanometers to ammeters. Conversion of galvanometers to ammeters. To convert a galvanometer to an ammeter, all you just have to do is to connect a low resistance resistor in parallel with the galvanometer. To connect a low resistance resistor in parallel to the galvanometer. So that's how to convert the galvanometer to an ammeter. You are saying to convert a galvanometer into an ammeter you connect a low resistance resistor in parallel to the galvanometer. Now, this low resistance resistor that we're talking about is what we refer to as a shunt. That's like the process of converting the galvanometer to an ammeter is called shunting. You understand? The low resistance resistor or the low resistance device is called a shunt. That's what we call a shunt. Are you getting me now? That's what we call a shunt. You see that now? Now, that's what we call a shunt. Let me recapitulate for those of you that are just joining in. For those of you just joining in, we said to convert a galvanometer to an ammeter, you do so by connecting a low resistance, which we refer to as a shunt, in parallel with the galvanometer, and that will be the first mechanism in converting your galvanometer into an ammeter. Now, this is going to be the setup. From what we just said now, that's connecting in parallel. You are saying if this is our galvanometer G, you have to run parallel to this galvanometer another resistor that we call the shunt. I get it now. So this is called the shunt. This is called the shunt. Now, when a current I is passed through this system, just follow it because it can ask you to explain the conversion of a galvanometer to a shunt and to an ammeter. Now, when this current here flows into the cell, I get it as flowing into this place. When it gets to this junction, the currents are going to split. When it gets to this junction, the currents are going to split. Some current will pass through into this place to run and supply the galvanometer, and that current is what we call IG. While some current will go down to come and supply the shunt, and that current is what we call IS. I get it now. IG will come to supply the galvanometer, IS current that flows through the shunt. Okay, having known that now, then we can now state from this that in a parallel connection, we know from our last class that voltage is constant. So I saying the voltage here is still the same voltage in this region. Since in our last class I said the parallel connection voltage is constant. So we are saying since in a parallel connection, voltage is constant. So we're saying the voltage in the galvanometer, therefore, the voltage in the galvanometer has to be equal to the voltage that is running through the shunt, that Vg equals to Vs. Of course, you can recall that what V is equal to IR. In our last class, we talked about this. So substituting this expression into this single expression here, I get to now into this expression here. You can now say, instead of saying Vg, you say IgRg. That means the current flowing through the galvanometer and the resistance of the galvanometer. You say IgRg is equals to, for the Vs now will become what? IsRs, and is current of shunt multiplied by resistance of shunt. Good. Remember that what we're emphasizing on is the current of the shunt, the current that will flow through the shunt. You get, so we can, let's make the resistance of the shunt. We want to know what resistance must be connected in parallel to the galvanometer. We want to know what resistance must be connected parallel to the galvanometer. Okay, so let's make our RS the subject of formula here. So I'm dividing both sides by IS. So IS cancels IS. We are left with RS equals to what? Or left with RS equals to IgRg over IS. IgRg over IS. Now, do you agree with me? We agree with me that since in this beginning here we said this current I flows through, I get this is the total current that was flowing through, and when it got to this junction, it got deflected. I get to be some current flow here, some current flow to this shunt. Okay. So we can say that the total current I is equal to Ig plus Is. I get it. You can say I is equal to Ig plus Is. And since we know that I is equal to Ig plus Is, that is Ig plus Is, then automatically you can make Is the subject of formula. That means you can still say Is is equals to, if you carry this Ig here, you'll be having I minus Ig. So substitute Is into this place. Since Is is equal to I minus Ig, you can substitute that into this Is and we'll be having what? Rs, which is resistance of the shunt, equals to what? Ig Rg divided by what? Divided by, instead of writing Is, we know Is is I minus Ig, we now say I minus Ig. So please, let's write down this formula. Let's write down this formula. So this is the formula for calculating the resistance that flows through a shunt. That's the formula for calculating the resistance that flows through a shunt. So quickly now, please just quickly write it down. If you don't understand, please drop your question in the comment section. Please, can I wipe it off? If I can wipe it off, just tell me. You can actually take a screenshot. Remember, you can just take a screenshot. Then when you take your screenshots, I can wipe it off. You can write all these details later so that we can solve some problems first from here. So this, you can be asked to explain the process of conversion of galvanometer to ammeter in your JUPEP. When you are asked to do that, maybe your JUPEP or any other exams you're writing, if you are asked to do that, you are not just to write this, you have to write this, draw the diagram, and give the mathematical illustration that enables us to divide the resistor, the magnitude of that resistor that we call the shunt. You understand? So let's quickly do that. Let's write it down. If I don't write it, please signify so that I can just quickly wipe it off and resolve questions. Are we done? Are we done? So if I don't write it, please signify. If you don't understand what I just said, you can also ask question. Please, this is just the formula you need to take note of. RS equal to IG, RG over I minus IG. Because you can be told, if they will ask you this question in the exam, they will tell you, calculate the magnitude of the resistor that must be connected in parallel to enable the galvanometer measure a deflection current of so and so. So that's what they just tell you. You just apply that expression there. So I was able to see like 3 questions a bit from your GPA past question, and I'll be reading them out for us to solve. Please, if you are done writing, signify so that I can move on. Okay, one person is done. How about the others? I'm waiting. All right, so I think I can wipe it off. So let's solve some problems. Let's solve some problem in this aspect. So this question says, a galvanometer of resistance 5 ohms a galvanometer of resistance, a galvanometer of resistance 5 ohms, has full scale deflection, has full scale deflection, for a current of 100 milliampere. For a current of 100 milliamp. How would its range be extended? How would its range be extended? How would its range be extended to 1.0 amp? To 1.0 amp by placing now this is the question. Quickly write it down before we solve it. Quickly write it down, so solve it. Now, this stupid question, what we want you to do specifically, they didn't even really specify calculate the current, calculate this. What they want you to bring out, or what they want you to point out from your definition, from your answer is what should be the value of the resistor, and how are you going to connect it? Of course, we are talking about, look at the first thing you are going to point out here. You are relating in this question galvanometers to ammeter. And since you are relating a galvanometer to an ammeter, automatically we know that we are dealing with the shunt. And when we are dealing with the shunt, automatically we know that we are dealing with what? Parallel connection. So we have to know what must be the resistance of that shunt that will enable our galvanometer to measure this amount of current, which was written here, 1 amp. I get it now. Then we will now say our answer is so and so in parallel to the galvanometer. So let's look for the magnitude of that resistance. How do we go about that? Hope you are following. Hope you are following. How do we go about that? A galvanometer of resistance 5 ohms. So if they said the galvanometer has a resistance of 5 ohms, so let's write it. That's our RG. RG is equal to 5 ohms. Are we seeing that now? Okay, let me come again. I said that the question says a galvanometer of resistance 5 ohms. So we wrote down our resistance. RG equals to 5 ohms. Has a full scale deflection for a current of this. That is the current that the galvanometer can deflect. The magnitude of the current can deflect is this 100 milliamp. So that is the current of your galvanometer, IG. 100 milliamp. Of course, we know we have to convert our milliamp to ampere, and that's by dividing by 1000. So we'll be having 0.1 amp. We'll be having 0.1 amp. Now, since we've been able to get our RG, IG from the question, let me recapitulate again for those of you that just joined in. Let me recapitulate. This is what we're trying to say. We're trying to pinpoint the fact that the question says a galvanometer of resistance 5 ohms, so we wrote our resistance of galvanometer 5 ohms, has a full scale deflection for a current of this. That's the current of the galvanometer. We're still talking about the galvanometer there. I get me now. Now, the answer said, how would its range be extended to this ampere? So I'm trying to say our total current I is 1.0 amp, because that's the range you want to increase your galvanometer to be able to measure. I mean, this is the total current that is released into the what? Into this circuit. Good. So what we are trying to look for is what ability or what resistance are we going to connect in parallel to be able to enable us our galvanometer measure this value of current. So I'm looking for RS, which is question mark, resistance of shunt. And I just gave you the formula. We said RS is equal to what? IG RG over I minus what? IG. And one thing that please somebody should start solving it to press in the calculator so that we can have our answer. What our IG? Our IG is what? 0.1 times our RG is 5 ohms divided by I total current, which is 1.0, minus IG, which is 0.1, and that gives us, this will give us 0.5, that gives us 0.5 divided by, when you subtract this, you should have 9.9 and 0.9. So our answer is equal to what? RS is equals to 5 over 9. By the time you divide, you have 5 over 9 ohms. So your answer will be 5 over 9 ohms connected how? Please you can tell me how we're going to connect it. Are we going to connect it in series or in parallel? I want to get straight. Is it going to be in series or in parallel? Of course, it's going to be in what? In parallel, because we are dealing with shunts. We are dealing with converting. The question is emphasizing galvanometer and ammeter. I get to be parallel. Good. Subami is very correct. So we're having in parallel, connected in parallel. And this value from what Subami gave us there. Okay, from what we're given, someone said that is equals to 0.56. 0.56. So that's going to say 0.56 on connected in parallel. It's very, very simple. Just understand the concept and you get it. Let me give you guys one question to attempt. Quickly write this down. Write this down. I will just drop one question right now. Write this down. Let me drop one question for you to attempt. Quickly. If you are done writing it, please. If you are done writing, just signify, or you can screenshot. Okay, Shubomi, are done. I want to give you guys just one question, and we'll move to the next concept. Shubomi, hope you understand what we're doing. Hope you all understand what we're doing. There's no complexity right here. Understand? It's very, very simple. I think I prefer the white light. Okay, who else is done? Okay, I think I can clean up now. You guys can screenshot if you are not done writing because of time. I want to just give you one question to attempt. And the question says, the diagram below, the diagram below illustrates the conversion. Illustrates the conversion of a galvanometer to a shunt, to an ammeter rather, of a galvanometer of resistance galvanometer of resistance 2 ohms to an ammeter. Of course, you can start something as I'm writing. You of course know that these 2 ohms here is talking about the resistance of the what? Of the galvanometer. You get it? Now they also gave us that the galvanometer gives a full scale deflection. Then the galvanometer gives a full scale deflection. This is a full scale deflection for a current of 10 milliamp. For a current of 10 milliamp. For a current of 10 milliamp. Calculate the value of R. Calculate the value of R. So look at it, they gave us the diagram. They gave you the diagram there. They gave you the diagram. Jessica, you are just joining. They give you the diagram, and the diagram is this. You have your galvanometer. This is another sign for galvanometer, don't be confused. And they drew the diagram there that is connected in parallel to this device, which is the resistor, we know. And they labeled it for you already, RG, based on the questions there, it's giving you the question also 2 ohms Then they put your current in for you, the total current flowing. You understand which they said is 10 diagram now. This was not stated in the question, but they put it in the diagram now for you. You understand? So that you don't get confused. Then they also showed here that the current that is flowing through this galvanometer, they showed you that it is equals to 10 milliampere. 10 milliampere. That is the current flowing through the galvanometer. That is your IG. You understand? Then they also gave you your R value. They said find your R. So that's the question. And I want you guys to attend that question. I'm giving you a very split second to get the question. I'm giving you a short time to get the question. Oh, Desire, I already said it on the group. You connect, and I told you already how to connect without the link now. Just for you to join in, or you click on Periscope, type the Eris impact, come out, you see it. So please, let's just do fast. I'm giving you exactly 2 minutes for you to get the answer. I've already given you, like, they've given you your current. Make sure you convert your galvanometer current to ammeter is in milliampere. It's a milliampere. Make sure you convert it to ampere. And I've told you that dividing by 1,000. Then they've given you your resistance of galvanometer. This R here, of course, is your resistance of shunt. You get, they want you to get this R, which is the resistance of shunt. And this is your total current, which is I. This is your total current, which is I. You understand? So I'm giving you guys 2 minutes quickly to attempt the question and get the solution. Two minutes, exactly 2 minutes. I'll solve it if you don't get your answer. Nobody has dropped any answer. You guys should be fast. And I told you already, by next week, I'm going to really be on real drilling course. I get you guys will have to be reading ahead. I dropped materials for your biology, for biology students, biology 04 and biology 02. From next week, our biology classes will be audio also and video. Understand? It will be video because I have to be doing some real demonstrations. You get it will be video. So get yourself prepared. I told you our classes from 10 from next week. From 10 to 2, 10 to 1, 10 to 1:30. Okay. Show me I dropped an answer 2.002 times 10 to the power minus 3 connected in parallel. Let me see. Yes, that's very, very correct. Very, very correct. Very correct. So you got that answer right, Chubomi. That's kudos to you. Now, this is